Heine, Allan, I don't know how to say your last name. Okay, Hottovy. Elliot McCarthy, and Sandy. So, please. So just a little bit while they're getting ready, I'm going to be moderating this one too, which will be also fun. Nice to meet you.
I think it's set in California.
No, I'm not from California, but I travel a lot. Yeah, no. Oh, yeah, we did meet in California, didn't we? You know, it's hard for me to remember all the good-looking men that I met. You know, in this industry, there's so many. Well, I talk loud enough that I don't need to stand behind the podium. Everyone can hear me. Are you guys okay in the back? Okay, good. I'm going to let each one of the panel introduce themselves. Sandy, you can, tell a little more about yourself if you'd like, but I'll just have you go down the line. And essentially what I'm going to do is I'm going to ask them questions, and if you guys want me to stop, we can, or we can ask questions at the end. It's up to you. What do you feel like doing? Questions at the end? Okay. We'll do it that way then, so the flow just keeps going. Sandy, we already...
So
Go ahead.
I think I've already talked about this information if you want to get in touch with me. I've been in IoT work for quite some time now. The interesting thing is last 2 years I was running an internal startup within Intel focused only on IoT. And but I'm not at Intel anymore. So I might pursue that outside.
Good morning, everyone. I'm Paul Heine. I'm with a company called SICK Incorporated here in Minneapolis, headquartered here in Minneapolis for North America. I've been with SICK for about 15 years and in the automation space, 22 years. Sheesh, it's amazing. Anyway, I am a subject matter expert on IoT for SICK, and obviously SICK is involved with a lot of different sensing applications, so I work in that space on actual customer projects.
Good morning, my name is Elliot McCarthy. I'm the Field Director of Engineering for Motion Solutions for Omron. I've been with Omron for about 1.5 years. I've been in automation for about 20 years. Time flies when you're having fun. Do a lot of applications related to motion control, sensing, PLCs. Spend a lot of time in front of customers talking about IoT and its application.
My name is Allan. I'm from Telemechanique Sensors, part of Schneider Electric. I've been an instrumentation engineer for over 30 years, and I've had experiences in both in research and development, stress analysis, vibration analysis, testing for aerospace projects. I've done a lot of production quality control testing for Fortune 500 companies. I've also spent quite a bit of time doing predictive maintenance techniques and engine health and monitoring, both through trend analysis, order tracking, doing dynamic filtering and FFT analysis to extract data out of that. And then recently I've been more focused on automation equipment and stuff, so I have a pretty good physical understanding of the real world. And I've been doing high-speed data collection since the 80s, where we were doing, for vibration analysis, stuff, we're doing big data, and using data reduction, that's what we used to call it, to extract important data out of it and transmitting that to the bosses up above. So I'm more of a farm boy from Nebraska with an electrical engineering degree, likes to build stuff.
Wow, that's great. I'm not quite as sophisticated as you. So just so you guys can kind of understand where my background is. My background is factory automation and process control. I went to school for fluid power and then industrial technology. So I've been in this world since I was 7. I've been in it a lot of years, 20 plus, something like that. My background, currently right now where I am, I'm at Dell, and I am the subject matter expert for all factory automation, process control, and building automation. So I'm helping Dell with the convergence of the IT and the OT. So we're going to kind of talk about those things, as well as I want to talk about machine learning, just so you guys know, because I think that's really imperative. I want to talk about the benefits of where we're going with sensing technology in the future, and whether we do overlays or don't do overlays. Meaning, do we keep it separate from the control system or don't? So kind of think about those kind of questions. But the way I wanted, just so you guys know, you didn't have a chance yesterday, I'm going to go to each one of you to answer the questions versus just jumping in, if that's okay. Unless you feel really strongly about something, then let me know. Otherwise, I think it's better than you each get equal time. Okay, so the first question is, for me, is do you speak, in the room I asked asked this yesterday, but I want to make sure again. How many of you speak OT in this room? And how many of you speak IT in this room? So that's going to give you a gauge that we're going to speak about both the OT side and the IT side. I just like to make sure so that they're aware. So first of all, sensor technology is rapidly changing. How do you think it affects the OT side and the IT side when it comes to communication and collaboration? I'll start with
I look at the basic physics behind the sensors, whether I'm using a photo eye with light or an ultrasonic sensor with sounds, and the basic physics hasn't changed that much about how I actually convert the physical to the electrical. Then the signal conditioning techniques, we went from analog circuits to digital. Where I see the biggest improvement is more about what we do with the data. You know, we collect good data, it opens up a wide arena of different things. And so like, when I look at the development of sensors, it's more about the sensors have gotten smaller, less expensive, with automated process to build them. And they're really kind of hitting the limits on what they can do with that. It's all about what type of data I get out of it and how I analyze it into some type of solution that someone's willing to pay for. And to me, there's been a tremendous ability on the software and the analysis side is probably where most of the development has been done in the last few years, and also in communication protocols.
So back to the question, how is the IT and the OT guys going to collaborate when it comes to that sensor stuff? Because that's what's, I think,
I've been
really
at Caterpillar, United States Steel, pulp paper refineries, all types of oil guys, and that is the biggest battle you got, is taking data off the machine and getting across that frickin' firewall into the managers outside someplace else. In fact, the strategy we used was physical disengagement. It's like if I had to go in and troubleshoot something, I had to sit there and call in on my manufacturing VPN license. The local operator had to physically plug it in to the system. When he got done, he pulled that thing out as fast as he can because he didn't want anybody messing with it. And to me, I think that's a big battle because the OT guys it's about reliability and long-term life of the machine. That's what I want, repeatability. The IT guys, it's fastest, greatest, biggest, baddest speed. You know, it's more about data movement. I mean, we're in the physical world, have a bunch of machines working together, so I think that's going to be a really big battle.
So Paul, working for a sensor company as you do, how do you feel that it's changing?
I think from the IT and the OT side, I think maybe somebody said it best, you want to bring the right people to the table and get the right groups involved early so that they can see that they're operating towards the same goals and towards management goals and objectives. And that's an important piece of it. I think, you know, just a mutual respect for the kind of things that happen on the factory floor versus what happens in the back offices in the rooms where the data is processed and sent is important as well. Just jumping on to the previous comment earlier about sensors, totally see the digital movement on sensors. A lot of application-specific ICs are now integrated. The potential for data has increased enormously. There's a document that I'm privy to on one of our products that is 1,800 pages long with command strings that you can write to it and get data back. Our challenge has always been making customers aware that this kind of data is available and they can get it and use it. And so that's very difficult when you have an 1,800 page document. No one wants to read that, of course. So.
Would you like to go?
Sure. We got a lot of OT and a lot of IT people in this room. I don't have to really tell anybody the never-ending battle between IT and OT. Your IT people always focused on security and we need the latest updates, the latest security patches. OT people are more, well, it's just, you know, just a device and, you know, it's secure because I buy it from a reputable company. Neither really believe that it's going to be a problem to integrate. I think you need to get champions, both from the OT and the IT, that can work together, kind of like Paul mentioned. You got to have mutual respect for each other, and you've got to have a team that will understand the other one's needs. You've got to have OT people that understand that, okay, not long ago we had a Stuxnet virus, that previous to that, industrial control systems were immune from security issues, relatively immune. But that really kind of bridged the gap, and now we're starting to see some of the same issues in OT that IT has seen for years.
Did you want to answer that or should
I want to add, I think I cannot not emphasize the importance of security again. There is certain level of security that's given when I'm using my PC in an environment. Things get automatically updated, whether it's OS or security patches or what have you. What just in recently 5 years, a lot of horror stories have started coming out where people are getting into devices because they're so open, including traffic signals to oil refineries. Part of the reason why we were able to do a lot of things in Iran, for example, that was in our favor to be able to get there. But nonetheless, the fact that we can control these devices, if computer gone bad, at least my data information, somebody came to know critical data. But in a lot of other systems on the OT side, it's about life and it's about human safety. I could certainly from a remote distance can start all the sprinklers on my manufacturing floor, and that could create havoc. Or I can, in a power plant, I can start putting, I can open up the nozzles and start putting too much water out of my hydroelectric power station. That could flood a city down the river. These are horrible things that we have to take security extremely seriously and not mix those until somebody has really critically figured out. And last suggestion is do it in a piecemeal. Get one piece under control, move that, then go to the second. Unless you're, one additional point, I think we need to go back and impose this condition, a requirement back onto the sensor manufacturers. We cannot just trust and say, oh, they are well known in the industry, so everything will work. We have to go back and say there are the necessary checks and balances that are put in place.
So are you talking about root of trust then, all the way down to the silicon level from the sensor manufacturers?
Indeed. Part of the reason why I mentioned about having processing element and sensing in the same package was when stuff comes out, it's already encrypted, right?
So does everybody understand what I'm talking about of root of trust all the way down to the silicon? He could perhaps do a little better job than I can. But essentially what it is it puts a fingerprint all the way onto every single device and makes it an individual. That way you can actually see what's going to happen with each sensor. It has its own name, its own identity, versus it being lumped into, say, like a field bus system where you just have addresses, but it's in a node. So there's some things that are changing in that. So.
You said it quite well.
Okay. So that's just something to think about that's going to happen in the future. The silicon prices are coming down, so that's going to allow sensor manufacturers to more and more implement those types of things. That's a great one. So, requiring security on control systems and then working with the IT and the OT people, you talked about Stuxnet. Stuxnet was because of a USB stick. You can't cure stupid. If somebody wants to put something in there, they will, right? What type of security, I know there's new security companies coming out all the time, but what type of security tools and things do you guys, I know we're not talking about companies, but do you have any tools right now that are out there for customers to look at anomalies on protocols or anything? Because if they would have been able to identify that the protocol was tampered with, they would have been able to know there was a security breach. Anything here? Anybody?
I'll take that one.
Okay.
We have some system solutions that we deploy beyond just standard sensors. And so there's this balance and trade-off between giving us the ability to see what's happening to the system remotely, as well as protecting the environment for the customer. So there are systems that we utilize that allow us basically to knock on the door and say we'd like to come in and have our technician do these kinds of things, and they are logged, not only who the person is that's coming in, what they're doing, what they're intending to do, what they've updated, and there's always a go back function in case something is deployed that doesn't work. So that is one of the ways that we actually are engaged with the customer. In some cases, it is a physical push of a button on the customer side to say, we are going to allow you into the network to make these changes. And so there's a handshake or a coordination that occurs with that.
So that brings up safety. So security on a factory automation floor is not just about cybersecurity, but it's about physical security and safety. How do you think This should be handled between the OT and the IT side, and I'll start with you, Sam.
Can I go back just address one?
Sure,
thing?
absolutely.
I think the issue is going to be, before we get to the nirvana that you were talking about, there is a middle step, which is if you can have a policeman, meaning machine-wise policeman, a gateway, that sits in the middle between, as a connection between the sensing devices and going back to the IT world. This policeman's job would be, for time being, there are two types of problems, right? There are problems when security breaches are done by your own employee versus a non-employee somewhere out there who is not thinking, who is thinking ill about whatever you're doing. The outsiders are easier to control because you can set up a policeman. Internal, I don't know what to do. I mean, if somebody wants to sabotage, that's a different story. But at least you have a policeman in the form of a gateway who says whether this traffic is coming from the right devices or not. So in the interim, you can use that as a stopgap measure.
What do you think? No, not you, Paul. Sorry. I already let you talk.
You know, we talk about that, processes and software to help with this. I think the medical industry goes pretty far right now with like their CFR regulations requiring signatures and time and date stamps when changes are made. I think we learn a lot in that realm from the medical industry, and that those changes can come from either internal or external, and they have to be time stamped, they have to be date stamped signatures in order for the change to become effective.
I like it. I think a lot of it is what type of data you're sending out. I mean, most data on the plant floor is big, and it's really hard to transmit it to someplace. So we tend to very heavily process it and send it out. I know when I get a program that wants to go in physical change, I may have a different password set up for the service guys that are tied in the manufacturers of that piece of equipment. And then anybody outside is going to have a read-only. I think you got to really pay attention to what access you're giving them. Most of the internet things I'm seeing is processing the data into a usable format and send finished results out. They don't need to have access to the equipment to do that. They just need to collect the tags and files and stuff, and that data that's in the back, and do the analysis on that. So I think when you do the things like we're saying, and also be really intelligent about what type of data and changes you can make, you can walk people out pretty good. I also am a firm believer in the physical. I like to have a cable or a button that I push before I get somebody to go and change one of my machines. I don't want to just have some software thing in the middle of the night come and change my drivers. And that just causes problems.
Blue screen and death, those kind of things.
Okay.
So that brings up physical security, cyber security, computing at the edge versus the cloud. I think this is something that a lot of folks are talking about as well. Do we take that sense of data and do all of it up in the cloud, or do we do it at the edge? What's your feeling on that? What do you say? Yeah.
Well, that's a good one, because when you're doing vibration analysis and stuff like that, predictive maintenance and things like that, that's big data, and typically level 2 and level 3 guys already have that data metrics and all the stuff they can do right there locally. They don't want to take the raw data files and transfer them across the United States. Most people aren't even going to know what to do with them because they're big, gigantic files, on it. So I lost my train of thought on the data stuff. I'm sorry.
No, that's okay. I was just saying, how do you feel about data being at the edge or up in the cloud or both?
It becomes who's using the data. If I'm the predictive maintenance vibration guy or the guy that's responsible for facilities, I want to see my little alarms that pop up when that machine over there is getting noisy, and I might take my vibration guy to go out there and analyze it. So they're going to want to do that high-end, reactive, or actually more predictive type maintenance locally and take the finished results and ship it up remotely. But when I take all this data across machines, I'm a manufacturing plant across 30 different plants, and I got all these 10 horsepower blowers around there. That's where the cloud really comes in handy, where I can pull that type of data, event-driven data, not just the raw data, but some once a day when it's unloaded, I'm going to grab a data slice and stick that up to the cloud. So I use the analytics that's up there to look for trends and patterns and recognizing stuff that I just don't see because I'm in the mud. And so I think it's got to be a combination. You got to pay attention. Automation guys, it's about speed. We want it local. We don't have time to send it there and back. Process guys, it's accuracy, calibration, repeatability. So I give you my recipe, you can take it to wherever and build the thing over there if you don't want it. And you got to, it's hard. You got maintenance and facility guys. They do very probably the biggest data guys we got out there because everything they do there, it directly ties into the bottom line of the profit. If I can save $1 on a manufacturing process, that's $1 with the profit. You know, so it's a grouping of people.
So I want everyone to have a chance to answer this as they like, but the next question I'm going to ask is really about applications and use cases and return on assets. But how do you guys feel about the edge and the cloud? So I'll start with you.
So, if you look at hardware these days, you know, Omron actually has a processor with a Core i7 processor in it, which I think my laptop has an i5. So, right there tells you just the horsepower available at the machine these days. A lot of times you got to collect that data and process that data real time, and let's face it, the cloud is not real time. So when you process the data, maybe the results, maybe the trends is what you upload to the cloud, so that your upper management, your managers can.
Do with that thumbs up, thumbs down.
Yeah, they want it's running good or it's not running good. So that data gets processed to a final result for them, which gets uploaded to the cloud and tracked.
Paul?
Totally agree with what these guys are saying. We've been processing data on the edge, and I would say this whole movement to gateways and things like that is very exciting from a sensor manufacturer standpoint, because if you're a sensor manufacturer not into the automation control side, you're not doing a PLC or an IPC or something like that, you see that as a stopgap for you to send all of your data off to someone else. Well, now with gateways, we have the option to send data to another location and do other post-processing. So 2 pathways, I think, for data from the sensor perspective into the existing network, where you have PLCs and you can gather all kinds of data with the advent of IO-Link, which I think everybody on this panel is involved with, most sensor manufacturers are. That data is extra data that can be used locally in the existing control network. With gateways, now you're able to process other data that may be useful, more useful to upper management, and that makes sense. So the challenge and the challenging things that I heard early on was just send it all to the cloud. You know, send all the data to the cloud, and of course that's very expensive. It doesn't make sense in a lot of times, and so the implementation is always best locally, I think.
Or as you and I talked about before, Paul and I know each other, is the lights out manufacturing too, right? If all your data was stored up in the cloud, lights out if there's no power in your factory, nothing's running. So you have to make sure that you're keeping some of it local, right, which we've always done in a closed loop system, but then like they said, aggregating that up.
You look at all the successful cloud-based IoT things, they're services. They're providing the service. I mean, every one of them, you know. They had, they had that Nest, nice little gadget you put out there. Anybody bought one of them? You know, they just sold the gadget. They didn't sell the service like Uber did. They had all the hardware out there, and they figured out how to use it all together. I think a lot of the internet things is service. What's the maintenance guy want? What's the service is uptime. Production guy is throughput rate and profit. You know, on quality guy, you're providing them services with that data, and you got to make sure you understand the service you're providing before you start doing a lot of this stuff. And if there's no need for it, you got to kind of. I think a bigger battle was getting all the existing equipment to talk to each other.
Interoperability.
Yes.
We'll come back to that. I just want to give you a chance just before.
I'm going to go even a little more extreme.
Okay.
I'm saying not only cloud, not only edge, do the processing in the end node itself.
Mm-hmm.
Because if the connection between the end node and the gateway is severe, I want that end node to be intelligent enough to be doing its own processing and looking.
You see that
So
on
do you
DFT
mean the
drivers.
end of the wire, like the proximity switch itself, or the node that it's plugged into?
A lot of devices are on up, that's a different story. But
Okay.
a lot of devices that are looking at process continuously, you have a connection between the end node and the gateway. I'm saying, what happens if that goes bad? I want it to be so prove that the local intelligence along with the sensor itself can take care of it. That's two more points.
Okay.
I want to go 2 more steps ahead. One is, forget about even gateway. I want